So we're going to look at this quiz preview, work through each of the problems individually, and kind of see where we're at with some stuff. That's okay. Perfect. Love it. Perfect. So, first one. Here's my issue. Here's going to be my issue on the whole first group. We talked before about how that equals is kind of like having a wall here. If my x's are on opposite sides of the wall, which they are, I have to do the opposite to get them together. So what may I want to do here? Okay. Subtract the 2. So I got 3x over here, and again, still got my equals. Okay, right. That's right, because since I'm doing 3 times x here, the opposite is to divide by 3. X equals 4. And on these first 3, it's that same situation all the way through. In each example here, my variables are on opposite sides of the equal, so I got to do the opposite to get them together. So what's a good idea to start with for number 2? Minus the 3y. Oh, it's a step ahead of me here. And that's one thing I've noticed with some of you when you're on quizzes. You'll have a great first step, but then we'll forget something. Like some of you here will lose the 9 all of a sudden. I'm like, where'd the 9 go? So make sure you're copying things carefully as you get steps done. Okay, Taylor, now I'm ready. Minus 9. Again, whatever's the furthest away from my y is what I need to do next. And what's that last step going to be? And divide, because here I'm multiplying by 3. Y equals dose. All right, we're going bilingual. Okay. Okay. So one more on 3, and then we'll switch it up a little. Y's are on opposite sides. How do I get this? All right. Right, since it's a negative, I'll do a plus 3y. Okay, you can grab a different calculator if that one's... I know. All right. So I got to work on getting that 4y alone. How do I get the plus 17 out of there? Minus it. Okay. And then, right, my last step typically ends up being to divide. And I get my answer. Sure. If I've got something, somehow I ended up with a fraction in front of this instead, so like if I had x over 2 or 1/2 or something, then I'd have to multiply. But typically that last step is going to be a divide more times than not. Good question. Just seems like we do that every time. Occasionally, not very often though. All right, this one we're just going to read, and we're going to turn it into an equation. Okay. The question here is, how old is Mr. Harty? So that's our x. So let's see what we've got here. 2 times Mr. Harty's age, 2x, is, whenever I see is, that's the equal. Okay? 70 less than 4 times his age. Now, some of you may be tempted to do 70 minus 4x. Well, again, 70 less means I'm minusing the 70. Okay, so that's all we're up to. Okay, we could minus the 4x. Let me split screen this. I'll show you the other way you can do it in just a second. I think this is the better way because I like getting... I know. Well, I can show you how we can avoid the negative, but it's going to take one extra step. And divide by -2. Dang it, I wish I didn't do this problem quite right. I wish I were only 35. I'm 37. How'd I mess this up?
Harty's 37.
I know, Harty doesn't know his own age. So, Taylor asked a good question. He said, okay, when I originally set this up, I don't like getting negative, x's. What would happen if I minus the 2x instead? Here's the one dilemma, and here's the reason I don't like that idea here. Right, because what's left over here now is 0. And sometimes people will forget there's a 0 on that side, and they'll tend to just go, oh, 2x minus 70, and they'll go, I don't know how to do it. Yep. Right, it's going to take me one more step. Nothing terrible. But if you want to avoid the negatives, this is an easy way to do it. Same thing, same answer, just a little different way of going about it. So either one's fine. I just want you to really be careful if you go this route, though, because that 0 can kind of throw things off. All right. Ooh, another story problem. All right, 5. Michael rented a car from We Charge a Lot to You. They charge $25 per day plus 20 cents per mile driven. Allison rented a car from Our Cars Break Down. They charge $15 per day plus 35 cents per mile driven.
I know Our Cars Break Down.
Oh, wait till you see the ones on the quiz. They're even better. If they were both charged the same amount at the end of the day, how far did they drive? Okay. How far did they drive? X is going to be how many miles we drive. So, yes. No. So, they charge $25 per day plus 20 cents per mile driven. How would I write that?
25x. No, 25 plus 0.20x.
Okay, now hang on. Wait. Hang on. Here, how I know the 25 doesn't get the x's, we talked about this before. Okay, right. $25 for a day. I'm getting charged $25 whether I drive 1 mile, 20 miles, whatever. But the per mile driven, okay, that's where I kind of figure this out. For every mile I drive, that's going to cost me more money. So then, the other half, kind of using this as my example, what's the other half of my equation going to look like? 15 plus, there's that per mile, 0.35x. And now I'm ready to solve it. So this actually can be used as an application. Here's my wall still. My x's are on opposite sides of it. Okay? We don't like the negatives. We just keep stressing that. Alright. So I got 25 left on this side of my equals, because the x's are gone. 35 minus 20 would be a 0.15x. Now what? Okay, right. Because I want the x part by itself. So subtract the 15. Definitely didn't do that on purpose. So, the next part takes like what we were doing in 1 through 3 and adds. It's going to say, and get the earbuds out, please. It's hard. I can't compete with whoever you're listening to. I can come up with cool story problems, but I don't have that much talent to compete with whoever those people are. All right. Distribute this. 12x plus x 12x minus 4. Okay. Now what? X's together first. When I minus the 12x, goes away on both sides. Does 6 equal negative 4? No solution. Okay, so if all of our x's disappear, it's either no solution if they don't equal each other, or it's all reals if they do. That could come in handy here in a little bit, maybe. But whenever we see those parentheses, those have to get taken care of first. So what's this going to look like once I distribute? Okay. The biggest thing here is remembering when I'm distributing, okay, remember you're multiplying, and a negative times a positive is a negative. It's up to you. Okay, we can add 9. Even though if you did subtract the 4d, you can end up with the same answer at the end. Negative 18 down to 60. Now what? Okay, subtract the 60. Because I'm adding it to the 13b, and since it's a positive 60, I do the opposite, which is minus or negative. Yeah, because remember, when we're adding, negative. Correct. Negative times negative is positive. D is going to be negative 6. I know, gracious. All right, bump up a little more here. All right, let's see what we got here. So, what's it look like? We'll take care of it here in a minute. And distribute through first. What do I have to do next? I have to shut up next? No. Okay. So right. Is 24 equal 24? Yes. All real. What's that? The same time we were doing no solution? It may be. Maybe. All right. So, number 9. See the parentheses? Got to distribute. Be careful. Yeah? Good. Negative times negative is positive. Now what? Subtract the 16. I am with you. Divide by negative 2. 1.5, yes. Yes, yes. Okay. So you start, well, but we're starting to see some patterns develop, and we're also going to start heading towards the fractional. Tomorrow. Yes. So, as we flip over to the back, so what we're going to take a peek at here is, yeah, we're still going to be dealing with x's on the opposite side. Same side. Got the wall. What do I need to do first? We have options. What's that? Okay. Yeah, that was pretty good job. Get our x's to one side, our number to the other, and we got one step to go. Divide by 9. Now, okay, the sides I know that the numbers are different. What's the difference between number 10 and number 11? Okay, right. My x's are on the same side of the equals now. So now I don't do an opposite. I'm just going to combine them, but watch the signs. Negative 2x plus 5 equals... Yeah, but what I worry about is people tend to look at this and they'll do like plus 5, and all of a sudden I see 8x on this side. That makes me a little nervous. So yeah, but you're right. It still is like subtracting in this case. I have a positive and a negative. That's true. Well, let's see. If we minus the 5, either way is fine. I'm perfectly good with either way. If you get to the end, what's my last step on this one? Divide by negative 2. I don't care if you put negative 4.5 or if you just leave it as a fraction. I'm good with either. They're the same thing. But it's one of those things that as long as you're careful, again, 12 is a lot like 11, find those like terms that are on the same side of your equals, same side of your wall. So what's the left side of my equation going to look like? 12x minus 3 equals 9. Get that x term alone plus the 3. And then right, divide by 12 because we're multiplying. Oh, now the fun starts. So say if you weren't here yesterday, you can start seeing now how this is going to work. Yeah. My 2 kind of got blended in with my 1. Oh, yeah. Okay. We're going to keep life simple on these, like we did yesterday. Basically, take the numbers in the denominator, multiply them together, and that's going to be the number we multiply through by. Right. Because the reason we do this is, what's going to happen is that our fractions are going to disappear. 6 times 2 is 12, divided by 3 is 4x. 6 times negative 3 is negative 18, so even the whole numbers get multiplied. What's half of 6? 3. 6 times 1 is negative 6. And now it's just something normal like we've been doing. So how do I get the x's together on this one? Subtract it because they're on the opposite sides of the equal. And then just add my 18 over. Yeah, you could. The reason that I typically tell people to avoid dealing with doing the numbers first is they tend to get their x's screwed up somehow then. And I'm not sure why that is. Because they tend to want to combine like terms then when they don't do the x's first, even if they're on equal sides. I know, and right. And for some of you, that's just an easy thing to keep track of. Some of you, not so much. So just something to do. Almost there. I will get you there. I swear, I swear, I swear. All right. To the bottom. No. Yes. What am I going to be multiplying through by in 64? In 14. Okay. If you're comfortable with your LCMs, maybe it's 8, maybe you're doing 16. For the rest of us, we're just going to keep doing the same thing we've been doing. We're going to multiply the numbers together. And that's what we're going to times through by. Even though the numbers can get kind of big, we have a calculator, so that happens. 64 times 1 is 64, divided by 2 is 32x. Oh boy. 64 times 3 is 192, divided by 4 is 48. I'm with you. Woo! 64 times 7 is 448, divided by 8 is 66. What's up next? By 32. And this is one other thing to be careful of. A lot of you will look at 8 over 32 and write down 4 because you think it's 32 divided by 8. The bigger number is down below. So you're going to get a decimal or you're going to get a fraction for an answer when the bigger number is in the denominator. Just something to watch out for. What are we timesing through by on 15? Just 2. I only have one number in the denominator. Just 2. So we're going to multiply everything here by 2. Yeah, and I was going to say, this could really just be my one and only step, because 1x is really just x. So if I minus the 10, I'll get my 14, and I'm good. Just about there. Multiplying by in 16? Multiply my denominators together. And then again, yep, the process is multiply by the top number and then divide. So 18 divided by 2 is 6. 18 times 5 is 90. 18 times 1 would be 18 divided by 6 is 3. And 18 times 8 is 144. Now what? Okay, subtract that 3x. We like getting the x's together first. And right, my whole thing here is now I'm working on getting my epsilons. (34 divided by 3). No. What? 78? Okay. One to go. What am I going to be multiplying through by? Well, 12. That's what we're going to times through by. Alright. 12 times 4 is 48. Divided by 3 is 16. 12 times 2 is 24. 12 times 3 is 36. Divided by 4 is 9. 12 times 4, 48. Now what? Okay, get your x's together since they're on opposite sides of my equals. They're on opposite sides of the wall, let's say. We do an opposite. The equals does not move. To get 7x alone, what do? Add that 24. Divide by 7. This is going to be fractional or a decimal. 10.28. Basically, you have tomorrow's quiz in front of you. All I'm doing is changing a few numbers around. Just a few. No, not identical. I like doing stuff like that every once in a while just to see if people are paying attention, but not this one now that I just told you. Yeah, I've done that before. I have given out quizzes